Hello everyone, myself Vishal, and today I'm going to demonstrate how to integrate external relational databases to Kafka and stream data from that databases tables into Kafka topics. For that purpose, I'll be using JDBC Source Connector present under Confluent Kafka Connect plugin. I'll be explaining step by step how to create JDBC Source Connector config file and upload it to the Confluent server with the help of Control Center Gui. So let's get started. Alright, so I'm going to use the MySql database to source data into Kafka topics, and this is my table money transfer data, and this is the schema Kafka Connect. So this table I have created, and it has some data like sender name, sender account, receiver account. Basically it is a money transfer related data, and some of the records I have entered here. So what we're trying to do is that we will use this table to source this data into the Kafka topic. So let's jump into creating a connector config. Okay, so here I have created one JSON file with the connector config name. So this is actually just a file where we are writing the connector config. So the file name I have given is a money transfer data JDBC connector v1, the version 1.json. So always the connector configs are created in the JSON format. Okay, so that's why I have given the name JSON, and this is the common structure of any connector you write, no matter whether it's a JDBC source connector, it is a JDBC sync connector, or any connector. The structure of the connector config remains the same. Okay, so it starts with the one block, then the name, the unique name, connector name, and then we have a config where the actual connector config is written. Okay, so first we will change this unique connector name. Here we will add like the same one, the file name. We can put the same file name, transfer data JDBC source connector v1. Okay, so this is going to be our connector name. Okay, so within the config we will write our property. So here there are some properties which are common to all connectors, and there are some properties which are very specific to that connector whichever we are writing. Okay, so these are the all properties I have taken, the necessary properties I have taken. Okay, so all these properties are necessary. Some of them are common connector properties, some of them are JDBC source connector specific properties. Okay, so we will go one by one. We will understand what this property is and what value we should add there. Okay, so first we will go with the common connector properties. So first property we have here is the connector.class. So basically it is the Java connector class name from Kafka Connect JDBC plugin. Like I said before, the Confluent or the Kafka is the Java based platform. So any connector you are using there to build your connector config is actually a Java class. Okay, so here the connector.class name is nothing but the Java class name which you are going to build the connector. Okay, so we are going to build a JDBC source connector. So this is the JDBC source connector name. So I have given here. Okay, so it is present in the io.confluent.connect.jdbc source connector. So here you can see it is present under connect.jdbc. That means it is coming under Kafka Connect JDBC plugin. So we will use this one. We will use this, we'll put this value over here. So I'll remove this comment, add it. Okay, then we have task.max. This is nothing but the number of maximum task instance should be created. So when you deploy this connector config in the Confluent platform, right, so there are tasks created, and if you want to parallelize any connector, that means you want to read the data from the table in multiple instances, you want to multi-thread. In the Java language we call it as a multi-thread, or you want to parallelize the operation, then we provide the more than one task so that your operation to read the data will be faster. Okay, so here the number of tasks is nothing but the maximum number of instances you want to create for that connector. So I'm here at the moment, I'm giving only one because I'm running on my local machine, so I don't want to burden on my Confluent server, so I will give only one for demo purpose. Then we have key converter. So this is to convert external source system data. Now for us, the external source system data is the MySQL and the table data. So we want to convert that table data into a format which can be written into a Kafka in a serialized form. Okay, because the table data is in a different format. When we write into the Kafka topic, it should be in the different format. Okay, so basically there are three type of converters Kafka has been provided. One is a string converter, one which is used only for the single value data. If we have a single value, we want to pull the data from any external system, then it is a string converter. The another one we have is a JSON converter, and the one which is industry wide famous is nothing but the Avro converter. So I'm going to use the Avro converter over here. So this is the class name, here it is given io.confluent.connect.avro connector. So I'm going to use this connector from here. So we'll put this value here, remove this comment here. So I'll just minimize or put this in a bigger view. Okay, so key converter is Avro converter. Similarly, for value converter, I'm going to use the same one, the Avro converter. So I'll remove this and put that value. Now, when you are using an Avro converter, you have to specify the schema registry. So schema registry is the one component which starts when you start your Confluent server. Okay, so you have to give the URL for the schema registry. Okay, so schema registry URL is this one. It is running on my local, so it is http localhost 8081. It's running on 8081 portal. Okay, so similarly for value converter, the same schema registry URL. Now coming to next, we have the transforms. So transforms are nothing but the functions to be applied on key and value, key or value to transform into other form. So transforms are not mandatory. So it is like if you want to reform the data into another, another format, then we use the transform. So I'm going to use two transform functions. So here I give the custom names to my functions and then later I define them. So here I'm going to use two functions. One is a create key and second one is a set schema. Okay, so create key is the one I'm going to use to convert or to pull some value from the value format. Like I said earlier, right, the topic data is always in the key and the value format. Okay, so when we read the data from the database, it will always in the form of, it is always in the form of object. Now we want to create a key out of that object data, so that function I'm going to apply. And the second function is the set schema, which is to give a specific customized schema name to my value object when we write into the Kafka topic. Alright, so the second property is in line to my functions. Okay, so second property where I'm going to define the creates. So second property is where I'm going to specify in detail the functions. Okay, so my customized function name is a create key. So I'm going to write that property like transform create key dot type. Now type is the type of the transform function. Okay, so this transform function is this one. Okay, I'm going to use value to key class to convert the object or the data we read from the table. We use some properties or some column names to convert or to create a key. Okay, so this is my Java class. So I'm going to put down here. Okay, so this is the value to key type. Now second is that transform.create key.fields. Fields is nothing but the column names in the table format, language, the column names you want to use to convert data or to convert that column into a key format. So there are two columns I'm going to use. One is the transaction ID and second is the transaction date. Okay, it's a T not Y. Okay, so these two columns are present in my table. So I'm going to use this two column out of this value to set them as a key. All right. Now the second function which I'm going to use is the set schema, and here the type of the set schema is this one. So I will write it down here in the double quote. We'll remove this. Okay, this is my type. Now what name you want to give, what customized name you want to give to your schema name. So here we can give, since we are dealing with the money transfer data, so I'm going to use money transfer records. Okay, so this is going to be my customized schema name. Now further we have a JDBC Source Connector specific properties. Till now we have gone through the common connector properties. Now we will go through the specific property. Now the first and the important connector property specific to the JDBC Source Connector is to specify the database credentials. Okay, now the first property to specify is the connection.url. Here you specify your database. Right now I am using the MySql, so I have mentioned the MySql URL. If you are using another database, you can specify that. Then you have a connection.user, the username, connection.password, the password to the user to connect to the database. Then we have a dialect.name. Now I'm using a MySql, so I have mentioned MySql dialects. Okay. Then next property we have is a mode. So mode is nothing but the way to pull or read table data. Now when you read the data from the table, which way you want to read the data. Okay, so couple of valid values we have to select out of it. One is the bulk. So bulk means you will read entire table data no matter how much records the table have in the production. When you go to the production, so you will pull entire data every time when your connector make a connection with that database. Okay, that is a one option. Then but this option is not viable or not preferable when you go to the production environment. So what we have next next we have is a timestamp. Timestamp means you will have some column in the database where the timestamp gets updated when new record are inserted or new or any record is updated. So based on that timestamp you will fetch the latest data. Okay, that is based on timestamp. Then we have incrementing. So incrementing is nothing but you will have some column in your database which will be incremented as and when new records are inserted. It's like a serial number. So serial number like from 1 to some value which will increment one by one when you insert the new values. So the last option we have is the combination of timestamp and incrementing, which is the most preferred and the strongest way to pull data from the table. So I'm going to use the timestamp plus incrementing way to read the data. Okay, so I'm going to use this one and paste it here. Remove this comment here. So timestamp plus incrementing mode I'm going to use. Now when you use timestamp plus incrementing, you have to specify the column names which are used for timestamp and for incrementing. Okay, so the timestamp column name is transaction_date. So this column name I have in my database. Okay, and here transaction_id. Okay, so this is I'm going to use. Next property we have numeric.precision.mapping. So here the default value set is true and this numeric.mapping. So precision mapping is set to true and which way you want to use. Okay, so I'm using the way best fit. That means Kafka will decide what should be the best fit for any value which is coming from the table. So we have the table column that is amounts. For those amount values, it will fit, it will do its best to fit that value into the Kafka filter. So the next property is the query. So here query to read the data from table or alias or view. So basically Kafka connector does not allow you only to read from the table. It can allow you to read from the alias or it can allow you to read from view as well. Okay, so you have to write the query in such a way that based on this incrementing and timestamp column you are able to read the data from that table. Okay, so here it comes the query, here the table type. Now I'm going to use a table, I'm not going to use alias or view. So here I will mention as a table and here I will mention the query I'm going to use. So this is my query which I'm going to use to read the data. Okay, this is select star from and within the bracket I have mentioned all my column names like sender name, receiver name, sender account, all the column names I have mentioned along with the 2 column name which I am using for the incrementing and the timestamp purpose to fetch the latest data, that is transaction ID, transaction date from money transfer data table, and the alias name for that query I have given. Okay, so this is the query. So whenever it runs, Kafka always append this timestamp and incrementing column along with this query to read the data, to read latest data from table. Okay, now next we have is the poll interval. Okay, so this is the frequency in a millisecond to poll new data from table. Okay, so how much, after how much time you want to read the data from the table, so this you have to mention. So I will mention here, after every 5000 milliseconds, that is after every 5 seconds, you poll to the database to check for the new data. So the next property we have is the batch.max.rows. From the name you can understand it is the number of maximum rows you want to pull from the table when you make a request to that database to read the data. Okay, so here I am going to give one small number to visualize when we deploy this connector onto the Confluent platform. So I am going to give here some number like 5, but in the production environment this number should be at a higher level, like 500 or 1000 records you should read when you build the connector. Next property we have is the topic.prefix. Basically it's a topic name where you want to push the data. So the topic name I am going to use here is a money transfer data v1. Okay, so this is the topic name I am going to use. So first we have to create this topic name and then deploy this connector to make it working. And the last property we have here is the db.timezone. So it's basically the time zone where you are running this connector. So right now I'm running this connector in my time zone, so I'm going to use that time zone here. So my time zone is Asia, Kolkata. Okay, so this is the Indian time zone I'm using. So this is all about our connector config. So we are able to build a connector config here. Now we will deploy this connector config onto the Confluent platform and see how it behaves. Now here I am on Confluent Center. So first I'll create the topic and then we will deploy our source connector. So I'll click on this add topic. The topic name is money transfer data v1, right? The one we gave in our connector config. Number of partition is 1 since I'm running on my local. So I'll click on this create with defaults. Alright, my topic is created. Now I'll go to this connect. Within this connect default, here I will add my connector. So I'll click on add connector. I'm going to deploy my connector config or upload my connector config. So I will click on this upload connector config file. It will refer to my location where I have created this connector config. Connector config JSON file. So I'll click on this. Now here you can see it has imported all my properties from that file. Okay, everything looks good. I'll click on next. So this is the connector config, this is the connector name. Okay, this is our topic name. I'll click on launch. Now you see this connector is deployed, task is created, and it says the status running. Okay, that means it started to poll the data. Now we will go to topic, see if the messages are coming. Now here it says fetching data. So I'll go to this money transfer data v1. Okay, within messages. Okay, here I'll check from partition 0 and offset 0. So if I add it, here I have 12 records added into my topic. So I'll change this view. So here you can see these are the number of messages or the data we receive from the table. So if I just enlarge it, see the format. So this is the format of my schema for the value. This is the schema of my key. So these are the values we are getting into our Kafka topic. So if I go to the schema tab, so this is the schema which got generated when the table records are getting added into Kafka topics. Now if you take a notice, the connect name or the schema name is money transfer records. So this is the same name we have given into our transform function to set the customized name, right? So this is the name. Okay, so if I go back to messages, we as of now we have total 12 records added. Now I will try to add more records into table and let's see if this reflects here. Okay, so I'll use some of the insert commands from this SQL. Okay, I will run on my table, okay, along with commit. Okay, so I will run this. Okay, so all these records has been inserted. Now our offset should have been increased. So if I go back to Kafka topics, okay, if I go to this view, now here see earlier the offset was 12, now the offset has been increased to 18. That means new records has been reflected into our Kafka topic. So this way you can integrate external database like MySQL, Oracle or Sybase, any other database to source data into Kafka topic using JDBC Source Connector.